So consider a perfectly flexible elastic string stretched between 2 points at x is equal to 0 and x is equal to L as shown in this diagram over here with uniform tension T. If the spring is displaced slightly from its initial position of rest and released with the endpoints remaining fixed, then the endpoints will vibrate. The position of any point P in the string will then depend on its distance from one end and on the instance in time. Its displacement U at any time T can thus be expressed as U is equal to f of x T, where x is the distance from the left-hand end. The equation of motion is then given by the partial derivative of U squared. So del 2U del x2 is equal to 1 over c squared del 2U del t squared, where c squared is equal to t over rho, in which t is the tension in the string and rho the mass per unit length of the string. The displacement of the string is regarded as small so that T and rho remain constant. So this is rho and not E. Now, I would like us to look at how exactly we go about solving the wave equation. So solution of the wave equation. So guys, to solve the wave equation, we list down all the boundary and initial conditions with respect to the drawing that we had here. So the boundary conditions, we have the string is fixed at both ends, i.e. at x is equal to 0 and x is equal to L for all the values of t. Therefore, u of xt becomes u of 0t. So at x is 0, then we have it as 0, and u of lt also is equal to 0, as you can see from the drawing here. U of xt over here is 0, u of lt is also 0 there. Okay, for all values of t greater than or equal to 0. The initial conditions, if the initial deflection of p at t is equal to 0 is denoted by f of x, then u of x0 is equal to f of x. So that is at time t is equal to 0. And let the initial velocity of p be, let's say, g of x. Then the partial derivative of u with respect to t at t is equal to 0 will be g of x. So now we want to look at how to go about solution, and we're going to look at the solution of the wave equation by separation of variable method. So the first thing that we are going to do is we are going to assume a trial solution of the form. So we assume a trial solution.